Okay, 1-8, addition properties, subtraction rules. I think I mentioned to you a day or two ago, but every year you get 1 day with the properties. Start with a few in 5th grade, in this case 3. However, we will cover properties again here in chapter 2 when we have 4 more and another one over here. So 2 won't be long, then we'll cover the properties again for multiplication. But for now, we're just focusing on what we know how to do, adding and subtracting. You have no idea how to multiply, you have no idea how to divide, you don't even know those things are things, because I've never showed you how to do them, so you don't even know what those words mean at this point. Right, think about that. The properties here, you'll see them on your quiz or tests. It'll show you an example like this, and then it'll say name the property used. You'll see it on the test. It's not the most thrilling part of math here, identifying the properties, but chapter 1 is filled with not so thrilling lessons. So once we understand, we're going to talk about the properties. What do they do? What do they mean? How do they help us? Well, then we're going to go over here. As you can probably see, there's some problems to solve. Clearly, the objective is not necessarily to solve the problem, but to apply a specific strategy or shortcut to solving the problem. Certainly, I could expect all of you to solve these problems without really any difficulty. So we must be doing something else. Once we do our adding and subtracting, it'll look more like this. This is the type of work we're going to do. So why do we need all this stuff now, Thatcher? Where'd you go? I thought you were going to get water.
I was, but then Miss Barkley.
Well, I'm not. Okay. Get out your notebook and shut the door, please. All right, just come in quietly. If it's going to be an issue, then this doesn't work so well for me. I don't need any of that garbage. None of it. I just need you to get your notebook. I don't know why it's brought in the room. Anyway, notebook. As you can see, we're 2.5 minutes into our lesson here. So we're going to go through the 3 properties. I'll explain what they are in some depth, and then we'll see if we can apply them to solve anything. So first up, 3 properties. Number 1, commutative property of addition.
Wait, it's commutative.
Let's quit doing that. Dominic, whatever that is there, making that rattling sound. So what this says is changing the order of the addends. Addend is one of the numbers inside an addition problem. But changing the order of the addends does not change. Yes, you do have to write this. Right, this is our notes. So, how did the book say it? Changing the order of the addends does not change the sum. Well, somehow we wrote it with word for word identical. I never even looked at what the book said until now. I've never had that happen. But the commutative property, and I'll give you an example. Changing the order of the addends. The addends is a number inside an addition problem. I'll bring it right back. But in this problem here, this number 7 would have 4 addends to it, a 9, a 3, a 7, and a 1. Each one of them is an addend. It is one of the numbers inside the addition problem. Does not change the sum. What does this word mean, sum? It pertains to adding, yes, but specifically it's the answer. Right. When we say sum, we're talking about the answer to an addition problem. What's the answer to a subtraction problem called?
Difference.
The difference, right. And I guess just for fun here, multiplying,
The product.
division, sweep it home,
Quotient.
quotient, right. So, right. So what we're saying here, and think about it this way. I could say 1 plus 2 plus 3. What's 1 plus 2 plus 3? Okay, 6. So if I did it in a different, let's say 3 plus 1 plus 2. What's 3 plus 1 plus 2? Okay, 6. What if I had 2 plus 3 plus 1? What's that equal? 6. Also 6. So what we're saying here is if we're just adding, add, if other orders of operation are in play, like subtracting or multiplying or stuff, then this rule doesn't work quite as well or at all. But for adding here, I can add things in any order I want. So when we're saying the commutative property, and again, they kind of pump it there, the $1 million word to remember is order. The order that I do things does not matter. The order of the add-ins does not matter. We still get the same answer. And I say it a lot to the older kids. 3 plus 2 plus 1 is the same thing as 1 plus 2 plus 3, which is the same thing as 2 plus 3 plus 1. That's the commutative property in a nutshell. What do we use that for? We use it for a scenario like this. And you don't necessarily have to write this down here. 4 plus 5 plus 9 plus 7 plus 5 plus 4 plus 6 plus 1. So I wrote a lot of stuff down there, and I could certainly go 4 plus 5 is 9, 9 plus 9 is 18, 18 plus 7 is 25, right? And just peel through it. But if I use the commutative property, I'm always trying to find groups of 10s, right? So let's see, a group of 10. Here's a group of 10 right here. Those two numbers add up to 10. I see another one over here. There's a group of 10, and you know what? There's another one right there. So I see 10 plus 10 plus 10. What do I have left that I couldn't group? The 4 and the 7? 10 plus 10 plus 10, which I can do in my head, that's 30, right? Plus 7 plus 4 is 11, 30 and 11, the answer would be 41. I use the commutative property to make that easier. I'm not saying 4 plus 5 is 9, plus 9 is 18, plus 7 is 25 is impossible work to do. But finding these little 10 families, you can peel it off. When we're just doing these little single digit things, pretty easy. But when we're dealing with some bigger numbers here, and again, we will have some opportunities to employ our rules from time to time here, and I'll point them out to you when they pop up on us. But we can find ways to make our life a little easier sometimes. That's what this is about. You can add things in any order you want. Okay? 2, associative property. A lot of people, when they write out their properties, will just write kind of the short thing there. I always kind of chuckle with some of these here because, you know, they'll have the commutative, so they'll write the COM property of addition, and the identity they just write like the ID property of addition. What do you think you write to shorten up the associative property?
Oh, no.
Right. Yeah,
No.
right. So there you go. So, yeah, right. So it's the, right. You can see what happens here. Well, the commutative is the COM property, the identity is the ID property, and then the associative is the, right. So I see that a lot, you know. That's okay. I know you're not swearing at me. Well, you know, do you really want to write out associative? If you want to shorten it up. For all practical purposes, if you just want to write CA and I for the moment, that's fine. Keena. Hello. So whenever you're dealing with the associative property, there will always be parentheses. Parentheses. And when we're saying parentheses, I'm talking these things right here, these brackety looking things here. Truthfully, in fifth grade, when you see we don't have enough properties to differentiate this from anything else here, but the only one of these three properties that deals with brackets is the associative. The others do not. And you can kind of see what they look like here. These are these brackets right here, right? And what they're saying with this property is, once again, you can ignore, kind of break math laws is what's going on here, because normally we're tied to the rules of PEMDAS. You have to do orders of operation in parentheses first. That's just the law of the land of math. However, if you're faced with nothing but addition work, you can break that rule. So you can ignore parentheses and add in any order you want. I bet me in the book didn't define this one the same way. What does the book say? Changing the grouping of the add-ins does not change the sum. I like mine. You can ignore parentheses and add in any order you want. That's all I'm saying.
Yours makes more sense.
Right. So what we're saying here is if we're still, they kind of do 5 plus 3 plus 2, and then over here, let's do it down here. 5 plus 3 plus 2. So what you would do here is, if I add these in the brackets first here, what's 5 plus 3? 8. And then 8 plus 2 is?
10.
I get 10, because PEMDAS tells you to do the brackets first. 5 plus 3 is 8. And then add the 2. And same thing over here. PEMDAS rules would tell me 3 plus 2 is, because it's in brackets, do that first. 3 plus 2 is? 5. And then I'm adding another 5 from over here. What's 5 plus 5? 10. So whether I did that first or not, it doesn't really matter. I could end up with 8 plus 2 is 10, 5 plus 5 is 10. I could certainly go 5 plus 2 plus 3, 7 plus 3 is 10. But if it's all adding, we don't really even need brackets at all. It's kind of, these rules have more application later on in your math life. Here in fifth grade, you're probably thinking, what and why? So fair, totally fair. There's just, you don't have enough knowledge to really apply these rules in all their glory here. So in a sense, both of these properties are pretty similar to each other for today. The only difference between them is the associative has brackets in it. The commutative does not have brackets in it. That's the difference between the two of them for the moment. But both of them, ultimately, you can add in any order you want, as long as it's add. If you have other orders of operation in play, these rules don't work anymore. They only work if everything's adding. Okay?
What if everything's subtracting?
There are no official rules of subtraction because we can rewrite every subtraction problem as an addition problem. Everyone. We add the opposite of it. We'll cover that a little bit later this year, towards the end of the year. We're going to rewrite our subtractions as additions. It's pretty cool. Just like every division problem can be written as a multiplication problem. Do you know that? Every division problem can be written as a multiplying and solved using multiplying division. Every subtraction problem could be written as an addition problem and solved using addition. Every single one. Truth. You'll learn it. Yes.
Would it be good to tell your viewers what the order of operations is?
You're gonna have that day coming up. Where is our order of operations day? Somewhere in here. 13, I don't know, chapter 2. You have an order of operations. Oh, look at that. Lesson 314. There it is. So when we get up to here, then we're gonna have the PEMDAS talk in more depth. Right? So we'll get there. Last one, the identity property, the ID. And this one's one of the easier ones to remember. Not always sure why we even need a property for this, but whatever. So 0 plus anything equals the same number.
So 0% is going to equal 0.
Right. No, I'm saying anything plus 0 equals itself, not 0. The multiplying part, well, we're going to modify that here. So the book says the sum of 0 and a number is the same as that number. If you like that definition, then write that down. That's how the book says it. Huh? Yeah. So what I'm saying is 0 plus anything equals the same number. So if I add 0 to 7, what does that equal? 7. 0 plus anything, in this case 7, equals the same number. 7 equals 7. If I said 19 plus 0, what does that equal? 19. 0 plus anything equals the same number. Not the 0, the other number. Adding 0 changes nothing. So for the identity property, the magic word you're thinking should be 0. When you see adding 0, you're looking at the identity property.
Do we have to write down the 0 word?
You would just write ID. I mean, if I said which property, just write ID. I know what you mean. You mean the identity property, right? Or you can write it all out. Identity property. If some people do, some people just go IAC. You know, I don't need you to endlessly write property. You know, they're all property of addition, property of addition, property of addition. So writing all that out every time is just kind of, we know they're properties of addition, right? So I don't need you to do a ton of writing. Okay, got it? 3 properties. So looking at the bottom of page 44, find the missing number, name the property of addition that is used. Your choices are commutative, associative, or identity.
Can we write that down?
Huh?
Can we write those down?
Number 1, you can write what I'm writing. 8 plus 7 equals what plus 8? So we see the equal sign like any scale. If I add 7 to one side, I need to add 7 to the other to keep it balanced. If I take 3 off, I need to take 3 off the other side. So 8 plus 7 equals what plus 8? Charlotte.
8 plus 7 equals what plus 8?
Yep.
What's that supposed to mean?
What goes in the box here?
0?
8. What's 8 plus 7?
7?
8 plus 7 is
15?
15. 15 equals what plus 8? What plus 8 equals 15?
7?
Yeah. So I'd put a 7 in the box there. Now, which of those 3 properties did I use? Did I use the commutative, the associative, or the identity property? Right. So I just write CLM there. Because the order doesn't matter. Just like I said, 1 plus 2 plus 3 is the same thing as 3 plus 2 plus 1. 2 plus 5 is the same thing as 5 plus 2. The order that I add things does not matter. All right, number 2. 8 equals 0 plus what? Give you a moment here. Number 2. 8 equals 0 plus what? So what am I missing in the box? Which of the 3 properties does this represent? Canaan. Missing an 8, and it's the identity property. Right. Anything plus 0 is itself. Number 3. 6 plus 1 in brackets plus 9 equals 6 plus in brackets 1 plus something. So what am I missing in that box to make it equal? Keep it equal. We know it's equal because the equal sign is there. Both sides have the exact same amount. So what am I missing in that box? Emma? A 9, that is correct. If I peel away all these brackets, it's just 6 plus 1 plus 9. 6 plus 1 plus 9. Right. And which property is this? Associative. There you go. I'll write it that way. If you forget the O, I mean, you know, I get it. It's all good here. But associative. So you see how they differ? The properties. Again, they do have value. We will unlock the value in our 4 years we'll have together to unlock the value. We'll unlock the value. Can ask Face, Colin, and Sam if we've unlocked the value.
And they'll say no.
Well, then I will destroy them.
I was told.
Destroy.
So your answer is yes?
Yes.
What does unlock the value even mean?
Oh,
I was told
Kata,
everyone
it's what we're
locked
gonna
the
so
value.
do here in 4 years. Oh, there's gonna be so much value to unlock Cana. Crazy value, Cana. Crazy. All right, next part. So, real quick here. Don't have too much time, but what we're looking for is similar to what I did before. So number 7 here looks like this. I see a 9, a 3, a 7, and a 1. And we want to add those 4 numbers together. So if I add things in any order again, we're looking for a 10 family. Do you see a 10 family somewhere in this addition problem? Thatcher.
I see 2 of them.
He sees 2 of them. What are they?
7 and 3, 9 and 1.
Right. So instead of adding 9 plus 3 is 12, 12 plus 7 is 19, and 19 plus 1 is 20. Again, I'm not saying you can't do that. But you could also say that adding 10 plus 10 is a lot faster and easier to do.
Yeah.
Right? So these things that we're doing here, these are more just little shortcuts for you. I mean, I'm not going to force, you know, if you get the right answer, I love how you did it, but we're trying to look for these little things here. And you've probably, I'm sure Mrs. Barkley probably went through 10 family stuff with you. She's real good at that type of stuff. You know, when you're adding 0 using the identity property, I mean, there's nothing. What are we doing? I mean, this one here, I could see 7 and 3 is 10, 5 and 2 is 7, plus 0 is kind of almost doesn't even need to be there to an extent, right? I mean, it's not changing the outcome at all, is it? At 0, so, you know, more or less discard those. Easy enough. All right, last part. So I can get you out of here. So find the missing add-ins. I mean, they go through it this way. Do you really want to talk about minuends, subtrahands, and things? I don't think you do. I don't think you do. No 5th grader wants to talk about that. So 17 says 6 plus something equals 15. And we're going to do more fact family stuff here. You can probably use your mind and figure out what the missing number is. What am I missing in the box? 6 plus what equals 15?
9.
9. So I'd put in a 9. Now, you can think about it this way. I'm going to write this out with the 9 already in place. But when we do fact families, 6 plus 9 is 15. 9 plus 6 is 15. 15 minus 9 is 6. 15 minus 6 is 9. That is a fact family right there with the 6, the 9, and the 15. I can write 2 addition problems. I can write 2 subtraction problems with those 3 numbers. So what you're trying to figure out is this is what we're trying to solve here, right? But which of these families here, if I take out the 9, stupid eraser, which of these 3 problems could I use to solve this same problem? Blank plus 6 equals 15. 15 minus blank is 6, or 15 minus 6 equals something. Which one? Number 1, number 2, or number 3? You would probably be able to use this one the most. Because this one I'm missing a part of the answer. This one I'm missing a part of the answer. But this one, all I do is subtract the 2 numbers to get the answer, right? 15 minus 6 is 9. So we're using fact families, yes.
I think the very top one would be the most useful.
Well, the very top one is the one we're solving for. We're trying to figure out what the missing thing is. So in a sense, we used subtraction to find the answer to our addition problem. Yes? Yep, I'll be done in soon. I'm already in overtime. All right.
I just put, those are the copies you need.
Try on your own, last 2, and then you're out of here. 8 plus something equals 14. And 22.
Do we have to make it
8
back
plus
family?
some, you do not. No, you do not. But you should be using subtraction. When I see this here, I see 14 minus 8 equals this. I see 13 minus 8 equals this. For any addition, you add the 2 numbers, but for subtraction, you've heard it before, you add up, subtract down, right? Because then you could go through, you could subtract, and then add it back together to put it back to where you start. So whatever the sum is, subtract, either add in to get the other add in. In a sense, you should be seeing 19 as this problem right here, not this, where you're grabbing at some magical number. If you can see it in your mind, hey, that's awesome, I love it. But you should also be able to recognize that I can rewrite these in a different form. If you can't figure out what the missing middle number is, solve a problem that you can solve. What's 14 minus 8? 14 minus 8 is? Anybody? I didn't realize 14 minus 8 was a stumper. 6. And that's what we're missing here, a 6. 14 minus 8 is 6. 8 plus 6 is 14. 13 minus 8 is? 13 minus 8 is 5. Therefore, 8 plus 5 is 13. All right. Homework, again, the first 6 you name the rule. The remaining ones you just solve. Should be a pretty fast lesson. Won't take you a lot of time, tonight's homework. Not as long as that rounding stuff you had to do. That is for sure.
That one was easy.
But it took so
So homework, if you're writing it in the planner, it is page 7, problems 1 through 33. It will not take that long. It sounds like a lot of problems, but you will realize many of these you can do in seconds or less, microseconds.
well, it will take seconds to write, but it won't take seconds to solve it.
Okay. Thank you. Where are you guys off